Welcome back. In this video, we're going to have a look at how we can go about simplifying algebraic quotients using our index laws. Now in example 1 here, we have 5x squared all divided by 15x to the power of 5. What we're going to do with this question is, firstly, we're going to simplify the coefficients that lie in the numerator and the denominator. Then subsequently, we're going to use the law of division to simplify out this x squared over this x5. So starting off with the coefficients, what we're going to do is we're going to start off by going with a factor tree of both 5 and 15. Now for 5, the factors of 5 are simply just 5 because that's a prime number. However, looking at 15, the factors of 15, we can't divide it by 2, but we can divide it by 3. And when we divide it by 3, it's going to yield a result of 5. So the factors of 15 are 3 and 5. So moving on from there, we're going to rewrite 5x squared over 15x to the power of 5 is the same as writing 5x squared all over 3 times 5 times x squared, 5. So our first step is factorize the coefficients. Now the next step leading on from here is we need to simplify the fraction where possible. So to carry this out, we look for the double ups between the numerator and the denominator, in which case we see there's a 5 and a 5 here, so we can simplify those by removing them. That's going to yield a result of x squared all over 3x to the power of 5. Now, a step after this, the step we're going to employ after this is looking at the rule of division when we're working with indexes or indices. What we find is that if we have two bases that are common and one is dividing the other, we take the powers and we take the power in the denominator and we subtract it from the power in the numerator. So what we can write is 3 stays on the bottom and then we get this x up the top here, so that's our common base. And then we're going to get our 2 here and throw that up. We're going to subtract 5 from it. Now simplifying this out, we're going to have a result of x to the power of minus 3 all over 3. Or we can rewrite this as 1 over 3 multiplied by x to the negative 3 like so. So this would be our simplified result down here. So we start off with 5x squared divided by 15x to the 5, which simplified down to a third x to the power of minus 3. Now example 2, we have 60x cubed y4 all divided by 42x squared. Now once again, the process we use to get into this question is we start off by simplifying or factorizing the coefficients. Now to do that, I'm going to use a factor tree. So I'm going to start off with my first coefficient 60 and I ask myself, can I divide this number by 2? And of course the answer is yes. And the factors will be 2 and 30. I take my 30 and I do it one more time and I divide it by 2, then I get 2 and 15. Once again, I look at 15 and I ask, can I divide it by 2? The answer is no. So the next prime number up is 3. So I go 15 divided by 3, which will yield 5. Now all of my numbers along this tree are now prime numbers. So the factors of 60 are 2, 2, 3 and 5. Now secondly, I'm going to do it with my coefficient in the denominator. So that's 42. Can we divide 42 by 2? The answer is yes. So we get 2 and 21. Can we divide 21 by 2? The answer is no, it's an odd number. But can we divide it by 3? Yes, we can. That will be 3 and 7. Therefore, the coefficients or the factors of 42 are 2, 3 and 7. Now rewriting this out, we can go 60 is equal to 2 times 2 is 2 squared. times 3 times 5. Similarly, for 42, the factors are going to be 2 times 3 times 7. Now going back to our initial problem, we have 60x cubed y4 divided by 42x squared. We put in our factorized form, so we go 2 squared times 3 times 5. Then we have a times x cubed times y to the 4. This is still all over 2 times 3 times 7 multiplied by x squared. Now our next step is we're going to go for the rule around division, so the index law of division. So what we're going to do is we're going to identify our common bases. So I've got a 2 here and a 2 here, a 3 and a 3. Then we don't have 5s and 7s, they're going to stay. We've got x's. So the next step is we're going to get our 2's, and we'll go 2, and there'll be 2, take the implied 1, multiplied by 3, 1, 1, take the implied 1, multiplied by 5, multiplied by x to the power of 3 minus 2, finally y to the power of 4. There's no double ups of this y. And that's still all over 7. Now simplifying this out, 2 to the power of 2 take 1 is going to be 2 to the power of 1 times 3 to the power of 1 take 1 is 3 to the power of 0 times 5 multiplied by x to the power of 3 take 2, that's going to be x to the 1. Then finally we have the unchanged y to the power of 4. And again, it's still all over 7. Simplifying this again, 2 to the power of 1 is simply just 2. 3 to the 0 is 1. 5. X to the 1 is just x. And y to the 4 is y to the 4. Simplifying, 2 times 1 times 5 is 10x y to the 4 all over 7. So what we've managed to do here is we've simplified 60x cubed y to the power of 4 all divided by 42x squared using firstly the factorization and the simplification, so cancelling out the common factors here, and then using our index law around division to simplify the variables or the common bases raised to exponents. So the difference between example 1, if it wants to load, in example 1 we used the method that we used in algebra of cancelling out common factors, whereas down here we used our index laws to effectively do the same thing. So we looked for the common base. In this case it was a numerical value of 2, and we treated it with the index laws. So we got the exponent 2 here, brought it up, and the exponent of the implied one, brought it up here, and then dealt with it that way, thus yielding the final result down here. Now, regarding the numerical values, we don't have to do it this way, as in we don't have to use the index laws on these numerical values, so 60 over 42. From a practical standpoint, what you would do is you'd go into your calculator and use the fraction key, and you go 60 over 42, and that would yield a value of 10 over 7. In example 3, we have 1715 multiplied by x squared z to the 4, all divided by 245 x cubed z squared. Now once again, we're going to go for the factor trees to simplify 1715 and 245. We could of course use a calculator, but we want to practice our abilities to factorize. So we'll go 1715, and we ask ourselves, can we divide this number by 2? And the answer is no, because it's an odd number. But then we turn our attention, can we divide it by 3? And again, the answer is no. So we go up, the next prime number along is going to be 5. Can we divide this by 5? And the answer is yes, we can. Reason we know is because we've got the 5 trailing at the back. So we can go divide by 5, and that's going to yield a value of 343. Now, we look at this number and we say, what can we divide it by? We can't do 2, 3, or 5 anymore, but the next one along is 7. Can we divide 343 by 7? And the answer is yes. Thus we get 7 and 49. And of course the factors of 49 are simply 7 and 7. So the factors of 1715 are 5, 7, 7, and 7. Now turning our attention to 245, we look at this number and we say, can we divide this by 2? And the answer is no, because it's odd. Can we divide it by 3? The answer is no. Can we divide it by 5? Yes, we can. If we divide it by 5, the remainder is 49. Factors of 49 are 7 and 7. Therefore, the prime numbers are 5, 7, and 7. Thus, the factorization is 5 times 7 and 1, 2, 3. 5 times 7 to the power of 3. And 245 is 5 times 7 squared. Now moving on to the simplification of the question at hand. 1700 or 1715 simplifies to 5 times 7 cubed x squared z to the 4 all over 5 times 7 squared x to the 3 z squared. Now our next step is we're going to use our index law around division to simplify this problem. So we've got a common base of 5. That's going to be 5 to the power of 1, take 1. So we're dealing with the 1 here and the 1 here. Next one along is 7, so we have a 3 and a 3. So we're going to go times 7 to the power of 3, take 2, multiplied by x to the power of 2, take 3, and then finally z to the power of 4, take 2. This is going to result in 5 to the power of 0, multiplied by 7 to the power of 1, multiplied by x to the power of minus 1, multiplied by z to the power of 2. Simplifying this out, 5 to the power of 0 becomes 1, 7 to the power of 1 becomes 7, x to the negative 1, well, we don't know what to do with that yet, so we'll just leave it as that. And then finally z to the 2 is z to the 2. Writing this out, we get 7x to the negative 1 z squared. And thus we simplify the original problem up here. So what this video has highlighted is how we can use the index law around division to simplify these algebraic fractions. Now we would have seen this before in our algebra topics, but what this really shows is the process going on demonstrating why we're able to simplify expressions like this down into expressions like this.